Hi, today looking at the PAP paper from 2012, going through question 6. So question 6 says to find the equation of the line that passes through the point 0,2 that just touches the curve y equals x minus 2 squared, for x defined strictly greater than 0. So what I'll do to start this question off is to start by sketching it down. So let's give it a small sketch. So what we're going to have is we're going to have the curve y equals x minus 2 all squared. Well, that's going to have a repeated root at x equals 2. So it's going to touch the x-axis x equals 2. So we're going to have it looking like this. Not like that, it's going to touch and come back up. So this is at x equals 2. And we're going to have some tangent to the curve that comes down like this and just touches the curve. And we know it's a straight line, so that's going to be of the form we know y equals mx plus c, for some constant c and some gradient m. Okay, well we know this line must pass through the point 0,2. So what I would do is, now we've given this little hint, I would try this question again using our form of a straight line and using the point that it passes through to find certain values and using the gradients of the lines to find the other value. Okay, so when it passes through the point 0,2, so what we can do is we can plug in x equals 0 and y equals 2. So plugging that into y equals mx plus c at 0, 2, this implies that c is 2, because 0 times m is 0, and then y is 2, so c is 2. So we know that y is mx plus 2. Okay, we're also told that it just touches the curve y equals x minus 2 squared. What that means is this curve is a tangent, this line is a tangent to the curve at this point. So that means their gradients are equal. So let's find the gradient of y equals x minus 2 squared. Okay, that means dy by dx equals, well, chain rule, 2 times x minus 2, x minus 2. So that gets you 2 into x minus 2 at some point x. Okay, well that means we know m equals 2 into, let's call our point x naught, so 2 into x naught minus 2, where x naught is where it touches y equals x squared. Okay, so what we can do is we know at this point the y values of these two curves, y equals x squared and y equals mx plus 2, are going to be equal. So we can equate them. So we can say mx naught plus 2 equals x naught minus 2 all squared. And we know m is simply going to be 2 into x naught minus 2. So we now have a quadratic for x that we can solve. So plugging this in, we get, well, mx plus 2 is 2 into x naught minus 2 x naught plus 2, and that's equal to x naught minus 2. So just to clarify, this is equating the y value here for y equals x squared at the point of intersection and the y value here at the point of intersection, which we're calling this point x naught. And it's replacing our m, our gradient, with the gradient we just found, which is the gradient of y equals x squared at this point. Okay, so expanding that out, we get 2x naught squared minus 4x naught plus 2 equals x naught squared minus 4x naught plus 4, which tells us that x naught squared minus 2 equals 0, so x naught equals plus or minus root 2. But we know from the question x is strictly greater than 0, therefore x naught equals positive root 2. So what we do is we sub this into our gradient, so we get the gradient is going to be 2 into root 2 minus 2. So we can now sub that into our straight line equation to get the final answer of, put it in red, y equals 2 into root 2 minus 2x plus c.